So electric potential due to a point charge in surrounding, there is charge particle Q, and at point P we are supposed to calculate the potential. I hope all of we know very well, potential at any point is determined as the interaction energy per unit test charge. It means if I put a charge Q naught here, what is the interaction energy? K Q naught by R. So potential at this point P is U by Q naught. I think we can get K Q by R. And again I am telling you, it is a scalar quantity, and this represents energy of a unit positive charge. Keep in mind, it represents energy of a unit positive charge, like this. Okay, potential energy of two charged particles in external field. Firstly, I will explain the last situation. In the last situation, we have discussed that the two charged particles Q1, Q2 separated by distance x, like this. And initially there were no external electric field. You bring Q1 from infinite, you say work done is 0. And you bring Q2 in presence of Q1, you say you do some work, Q2 into potential by 1. But in this situation, already some electric field is there. Due to that electric field, you say potential at the point A is given you VA and potential at point B is given by VB. Now please tell me, what is the work done in bringing Q1 from infinity to A? This is the work done in bringing Q1 from infinity to point A. Now you can't say 0 because electric field is there. So what you will say? Q1 and potential of that point. Similarly, you calculate the work done in bringing Q2 from infinite to their respective location P. You will say, if Q1 was not present, then it will be Q2 into VB. But Q1 is also present, so you will say potential due to Q1, that is K Q1 by X into Q2. Now you can sum up this equation and this equation and you get the final result, like in the Excel. Next point. Okay, potential difference. Again the same topic which you have discussed in class 10, but still you are supposed to know VAB. What is meaning of VAB? VAB means by convention it is VB minus VA. And I think you people can easily calculate VB and VA, need not to explain. Okay, again very good question. If the electric field produced by Q and Q dash is like in the picture given, and you say basically this is D and this is D, all of you intelligent, this should be 45 degree. If I say this charge particle is 1, this charge particle is 2. Potential at A can be written as potential due to charge particle 1, potential due to charge particle 2. Potential due to charge particle 1, that is KQ upon R. What is distance? I think graph paper is known to all of you. This is D, this is D, this is D. So you will say 2D. And what is Q due to Q dash? It is K Q dash by D. If we are able to calculate the relation in Q and Q dash, we are able to get the answer. Now in the diagram it is given that the net electric field is making angle 45 degree. It means electric field due to Q1 is equal to electric field due to Q2. one is this, another is this, they are equal in magnitude, then this is the resultant at 45 degrees. Even I think you can say kq by r square, you will say kq upon 4d square. What is E2? That is kq dash upon a square. Now you are able to calculate the relation in q dash and q, you put here and you get the result by solving it. So you please solve yourself, then you go to the next part. Analogous of gravity. Every time I am telling you this chapter is exactly same which we have discussed in the class 11th gravity. Now extended body, continuous charge distribution. I hope everybody is clear now. If it is extended body, we have to take the small elemental part, potential, then we will generalize it. Like here I am asking you to calculate the electric potential due to the uniformly charged rod at any point on axial line, that is a point P here. How will you solve it? Firstly, you pause the video, try to solve yourself, then follow my instructions. Suppose I say at a distance x, there is an element of width dx. Firstly, all of you say me what is the value of the dq, charge on this element. Yes, it is linear charge distribution, all of you intelligent, you will say lambda dx. And here charge is uniformly distributed, so lambda is q by L. Is it clear? Now tell me what is the potential at point P, potential at P due to this element, elemental charge. All of you will say me dV equal to k dq by x. Is it clear? And you sum of all such elemental charge potential, so you will integrate it to get the net potential at point P. You put the value of the dq, that is q by L dx upon x square. And I hope it is visible to all of you. Limit of the x is varying from r to r plus L. Now I am leaving this as an exercise for you. You please solve the integration, put the limits and get the result. This should be your final answer. I hope it is clear to you. Similarly, if I ask you another question. There is a rod of length L pivoted, or you can say located along the x-axis, has a total charge Q which is uniformly distributed. Find the electric potential P along the y-axis at a distance d. And it is written that rod means really thin, so we are not counting the thickness. Now you please pause the video, try to solve yourself, then you follow my steps. Okay, again you know the formula that you know very well. Firstly you have to take the elemental charge and you have to calculate the elemental potential, that you people know very well. So on this rod I take the elemental charge like this at a distance x of width dx. Now you please solve it. What is dq? Same lambda dx. You put the value of the dq here. Lambda is q by L. Integrating x is varying from here 0 to L. You please integrate yourself. I hope this is a standard result. I have discussed many times. Ln this should be modulus x. I think some of you must be knowing it. And if you are writing x, it doesn't matter, but please think it in that way. You put the limits and you will get this answer. This is the standard formula you are supposed to know. Ln x plus root x square plus d square. Okay. Again I am asking you, but here in this question lambda is varying with respect to x, not uniform, it is varying with respect to x. Firstly, tell me what are the units of alpha. That is simple for you. What you will say? Lambda equal to alpha x, alpha equal to lambda by x. Now you calculate the electric potential at point A. Again, due to this rod, I think we have discussed earlier also, you take the small elemental charge like this. K dq by r, dq is same lambda dx, and lambda is given to all of you. It should be alpha x. I think all of you know it. Again I am writing here. Lambda equal to alpha x. It is given in my question. Then you have to integrate it and you have to put all the values. You get this result. Okay. Equatorial point, as I told you, perpendicular bisector point like this. At a point P, at a distance y. Again, I know all of you know it. You will use the formula dv equal to k dq by r. Here it is k, dq is lambda dx, r is root x dash square plus y dash square. You can write it x also, it doesn't matter. Maybe there is a possibility I have taken with x dash here, but let me explain with on drawing the another diagram on the next slide, so you will get the idea. So we are discussing for the equatorial point of the rod. Let I say this is a rod of length L and charge Q is uniformly distributed. Length is L, so charge per unit length is Q by L. This is a point P on the perpendicular bisector at a distance r. This is L by 2 and this is L by 2. Okay. If we assume at a distance x elemental charge of width dx, I think we can write dq equal to lambda dx. And if I say the distance between P and this elemental charge, you will say root r square plus x square. Now, what is dv? We will say k dq by root r square plus x square. Then total potential at point P, you will integrate it, and when you integrate, you write the values. dq is lambda dx, lambda is q by l into dx upon root r square plus x square, and x is varying from minus L by 2 to plus L by 2. Some of you can write 2, 0 to L by 2 also, that is also true. Now how will you integrate it? I hope all of you know we always solve such integration by assuming that tan theta equal to x by r. We assume it. Then what is dx? R sec square theta d theta, and what is the value of root r square plus x square? I think it is r square plus x square is nothing but r square tan square theta. So what you will say, if I am not wrong, r square you can say only r, 1 plus tan square theta sec square theta half is there, it is r sec theta. So I put here all the values. Integration limit, you will say minus L by 2 to plus L by 2 k q. What is dx? I think it is r sec square theta d theta. What is root r square plus x square? That is r sec theta. So finally we get kq upon, I think it should be r, if I am not wrong, no, r can be cancelled, yes, r can be cancelled, so we have to read it, kq integration, I think it is sec theta d theta. Please check it. By mistake we have done anything wrong. Okay, yes, we omitted, we could not write this L. Yes, kq by L integration sec theta d theta. Now how will you solve integration sec theta d theta? Let me explain this again. How will you solve sec theta d theta? I hope all of you know, we have discussed in the basic mathematics part. Such questions can be solved by multiplying divided by sec theta plus tan theta upon sec theta plus tan theta d theta. Now you can use u equal to sec theta plus tan theta, and I think you can easily solve it, because you will calculate and you will get the form du by u, and you will get ln sec theta plus tan theta and plus constant of integration. So integration of this part is also can be written as kq by L integration ln sec theta plus tan theta, limit is given you minus L by 2 to plus L by 2. One thing you are supposed to know, here it is in sec theta. Sec theta value you can write from here. Tan theta you can write from this triangle. Put the value of the minus L by 2 and plus L by 2, and you get the result. So in the next slide I am writing the result. You please solve each and everything very carefully and then check the result. So I think you should get this result. And one more type, I will explain you the result maybe in this way also. Exactly same. Here basically I am using the standard formula that I have discussed many times, ln modulus x plus root x square plus y square. So you can do in this way also. We are using this formula. And this is, we are using this frequently, so please keep in brain ln mod x plus root x square plus y square. So up to last slide you are supposed to do it, then you can think if L is greater than y, then this is the expression, you please try to solve. Okay. Now we will discuss the electric potential at the center of a uniformly charged ring of radius r and total charge q. Again, what you will say? Continuous distribution, small elemental charge, small potential at center. We will say dV equal to k dq by r. Net voltage k integration dq is a net charge q upon r. Directly you can get it. One thing you are supposed to know, here we say charge is uniformly distributed. If charge is not uniformly distributed, then also we will get the same expression, because potential is a scalar quantity. So this is valid for non-uniform distribution of charge also, because potential will be same. Now I will show these steps. So these are the steps. This is our basic formula. We take the small elemental charge. This is the result. And even for non-uniform distribution of charge, potential at the center will be same. Okay. I think in the last class I have discussed regarding the electric field on the axial line of the ring. Now I will discuss the potential. Okay. Again, I think I can directly show you it. Firstly, we use the dV equal to k dq by r. Small elemental charge. Distance from the point P is root x square plus r square. And every charge on the ring is at the same distance. And potential, there is no role of the direction. Direct I write the potential. Now we will integrate dq, you will get q. This is the expression. Now please you try to get the expression for the electric field also. I am giving you the hint. In the last class we have discussed, I think this expression E equal to minus dV by dx. Just all of you remind, in the gravity chapter we have done it. Gravitational field intensity equal to minus dV by dx. Same thing we will do here. So you please differentiate yourself, and I think you will get the same expression which we have discussed. Kq x upon x square plus r square power 3 by 2. Let me show it. Please check it. Pause the video and check the result. We have to use this formula a lot. E equal to minus dV by dx. Okay. Now there is a disk of radius r, and you have to calculate the potential at point P on the axial line of the disk at a distance x from the center. Okay. So we assume this disk is made up of number of elemental ring. I take this is the elemental ring. And suppose I say of radius y, thickness is dy. Potential due to the elemental part is given by k dq by r. Here it is a ring, so r will be root x square plus y square. Each and every part of this elemental ring at a distance r from the point P. So I am writing dV k dq upon root x square plus y square. If I say sigma is the surface charge density, then I can write sigma area is 2 pi y dy upon root x square plus y square. And net potential at point P, you will integrate this. K you can write 1 upon 4 pi epsilon naught sigma 2 pi y dy root x square plus y square. And y is varying from 0 to r. Now again, such integration I have discussed a lot. Y dy root. We have discussed we can solve by putting x square plus y square equal to t square. But I am directly writing. I will say result is root x square plus y square. So I solve this part 2 pi. So I think potential at point P is sigma by 2 epsilon naught. And what is the integration of this part? Root x square plus y square. And what is the limit? 0 to r. Now you put the limit and please solve yourself. You will get this result, x square plus y is r square minus root x square minus 0 only x. So now I am showing the steps. Please see the steps. Like this is the elemental ring. sigma is the surface charge density, charge per unit area. You will integrate standard integration root x square plus r dash square, put the value and get the result. So this is the expression. Of course we have discussed, again I am showing it. There are two formulas, one is this formula, another is in the formula of the, you can say one in terms of the sigma, another in terms of q, any formula can be utilized. Okay, could you use this expression for the potential which we derived right now to calculate the electric field? And I am giving you the hint, E equal to minus dV by dx. Yes, you will get it. So you read it. Okay, let me, okay, if it is shown, you please do yourself. By mistake, slide is coming. Electric potential due to uniformly charged NS. Inner radius is small a, outer radius is small b. Again, you will calculate the potential on the axis due to the elemental charge k dq by root r square plus x square. Then this sigma, surface charge density, and I think you will say elemental ring of radius r, thickness dr. You will put the limit r is varying from a to b and you get this result. So you can solve yourself just as an exercise. Okay, now I will discuss